Project 2.5, Unpacked, the 595 shift register. So this here, as the title suggests, is the 595 shift register. Just like a 595, it can shift out bits, which are done through these inputs. So for example, if I want to shift in a 1, I would shift in a high here, and then 7 lows, 6 and 7, and then I'll just latch that. I'll explain all these inputs in a few minutes, and then we can reset it. If I wanted to shift in, say 129, we would shift in a 1, 6 zeros, and then another 1, and we can see binary 129. So this is all done with the central component of a D flip-flop. Now this chip is the SN74HC74 IC, or just the D flip-flop IC. It contains 2 different D flip-flops. Now a D flip-flop is essentially just a 1-bit storage device. It's very similar to the SR latch, but rather than needing 2 inputs, it only needs 1, and it also has an enable input. So the 2 inputs down to 1 is done through an inverter gate. Essentially, this inverter gate just means that whenever a low is provided, there will still be a 1 on the AND gate so that I can process through information. And then the AND gates, what they do is by tying in one of each of their inputs, it can make an enable pin. Now this enable pin is the clock pin of the D flip-flop, and it brings us to some of the pins of the D flip-flop. So the first is the clock pin. The clock pins for these registers are all parallel, so that when a clock signal is sent, the rising edge will cause all the bits to shift. Now the bit shifting is done from the D input, the data input, to the Q, which is the output. So this here button right here is the first data, and then all the other data inputs are linked to the previous register's outputs. What this does is that it means you can shift through bits. So for example, if I want to provide a 1, we'll see this bit here is going to shift from the 8th position or 7th position, if you count this as 0 or 1, to the next one. So we shift it in, and we'll see it goes through. If I want to provide a 0, it'll shift both of these out. So by linking the inputs and outputs, it will shift through simultaneously as well with linking the clock inputs. Each of these LEDs is used to show what I'm pressing. So this is the data, this is the clock for these internal registers, and I'll explain the difference in a second. This is the latch for the external registers, and then this one's for the reset. I have them kind of spaced out to see where this is actually happening. So the clock signal is provided by this monostable 555. It has 2 functions. One, it provides a rising edge clock signal, which is needed for the clock of the D flip-flops. As well, it's a debounced button. This is the similar setup for the external registers. The reset I have over here just to show where the reset pin is, and because this is pretty crowded, and the data just where the button is. So the D flip-flop also contains the reset, which is active low, and that's why this button, when I pressed, it goes low and it will reset. So if we shift in, latch it, and then press the button, we can see it resets. It's linked to all of the registers, the internal and the external. And then as well, there is a set pin, which is active low, so it's just set high because we don't use a preset function in the circuit. And there's a not Q, which isn't used. So I mentioned internal and external registers, and that's because the 595 is able to shift through 8 bits, but then it also has a latch feature. And this latch feature requires another 8 bits of storage. So in total, it actually has 16 bits of storage, in a sense. And this is done by essentially just making another 8 D flip-flops here. Now the latch pin, as I mentioned, is using the same setup as the clock pins of these. And that's because the latch pin is just the clock pin. On the rising edge of the latch pin, data is shifted in these registers from the input to the output. Now the input is actually the output of the internal registers. What this means is that when the latch is going high, the outputs of these will be now the outputs of these external registers. This means that data can be shifted in through the internal registers while keeping whatever data you want on the external registers. So if I shift in a bunch of ones here, we'll see none of this is lighting up until I latch the data. This allows you to latch only in certain conditions or latch at a certain time, and is an essential function of the 595. Other than that, I think that's the whole circuit. So thank you for watching. I hope you have a great day.